Thank you, Kim. And I promise to say the whole truth, the whole truth, and nothing but the truth, of course. And I do remember the event in Lyngby-Torbæk Library because I was there too. So why big data? Well, big data is something that came into being, I think, a long time ago. And I'm sure that you're all wondering, why are we talking about big data? Because hasn't big data always been around? And I would claim it has. And then again, during the last 3-4 years, I've come to some other conclusions that I had not thought about before. Being an engineer, people with technical skills tend to overlook, I think, some of the more soft skills and often make fun of them. And I've come to the conclusion that we actually do need some soft skills in order to understand what big data is all about. Okay, so this talk could not be given without the help of a lot of funding bodies and a lot of my colleagues and students and so on. So this is a mention of them, and if you want their names, I can give them to you. They're here, at least some of them. This doesn't cover all, but it does cover a few. So why big data? Well, we're all aware that data is changing the world and the way we think and the way we do business. So what's up on the slide there says that the world's largest taxi company owns no taxis. Uber. Largest accommodation provider owns no real estate. Airbnb, and so on. Continue. And this has all come to be because data has come to be so common, and the usefulness of data has been apparent to some of these companies, and they are really disruptive, as it's called. So what about DTU and the computer? Computer in the future. Will we have neither students nor research? Well, think about it. Looking across DTU at the departments at DTU, quite a lot of departments will claim that they actually do big data research. So DTU compute, of course, but also systems biology, the National Food Institute, the National Veterinary Institute, wind energy, management engineering, space and transport, just to mention some of them. And others will also claim to be there. So I think this is perhaps a point that could collect DTU, or gather DTU, make synergies across DTU, and this we have to think about utilizing. If we think about our own department consists of 11 sections, and each of the sections is mentioned up there. And each of the sections, to a greater or smaller extent, do have something to do with big data. And as we will look at it a bit further on, also together with the value chain of big data, we fill in very nicely here. So future directions could be the Internet of Things, we're already there. Machine learning, we're already there. Cyber-physical systems, high-performance computing, modeling, information technology, statistics, transportation, railway operations, and so on. And we're involved in all these things, and that, of course, is very pleasing. So the domain areas, where can this actually be used? Apart from being an interesting research topic, where could this actually be used? Well, there's something on intelligent energy systems and smart cities. DTU has centers on its way or ongoing in these areas, as you will see. Animal health and food quality and safety, which I will delve into in just a few minutes. We also have some interest and influence there. Healthcare, I saw that Jakob from Cachet was here, so here we have some interesting We have some interesting projects going on, and they also involve image analysis and system biology, and of course security. All this has to be protected somehow, and this is one of the issues that we have to talk about. Okay, the infrastructures, DTU is also quite well represented here. So we have some super computing facilities lying in Risø, in some big containers, so they're easy to supplement, part of the Elixir Pan-European research infrastructure. We have the Danish e-infrastructure cooperation, and we have right behind my office actually the High Performance Computer Competence Center. And I also noticed one or two from that center here. I borrowed this slide from Jacob E., whom many of you will know. And I like this one particularly much because it blends a lot of different things. So crowds, Bluetooth and rock and roll, understanding music festival participant behavior. And you will note that some of the names here are quite well known. Orange means, of course, orange scene. So this is an aerial photo of the Roskilde Festival area. And some of the other names represent other scenes across Roskilde Festival. Then, of course, there are these red dots with numbers on them, which are also quite interesting. And they represent places where DTU students have put Bluetooth sensors. And this was in order to capture devices like this one and see what's going on and at what time. So this is what a Bluetooth sensor looks like when it's made by a DTU student. It's a revamped Nokia something mobile telephone, robust and so on, but not absolutely waterproof. So they waterproofed it by means of an old lunchbox and a piece of plastic bag and some electrician's strips. And then it says, DTU experiment, do not tamper. Okay. So when I walk past the booth that has this Bluetooth scanner in it, then it registers that my particular Bluetooth is on, and it has this unique identification number, and it registers which time it came by. Now, if I walk by together with Per here, it will also register his phone, and of course the timestamp will tell that we passed nearly approximately at the same time. And this is information that might be interesting and useful to actually investigate. So things that you could do was that you could plot as a heat map each single scanner. Here's the scanner numbers 1 to 33. And you could show the activity, the Bluetooth activity on this particular heat map for each of the days and each of the hours of the particular day. And of course, there are certain times of day where there's more apparent activity than others. It's also apparent that some of the scanners are not, or sensors are not activated here. So this means that probably people are waiting outside the gates in order to get and grab the best tent placements for the festival, and then they rush in, and this is probably something around the tent area. Then something happens down here as Tuesday, Wednesday, Thursday comes on. You can see some of the more active sites are down here, and one of them is going to be orange scene, I'm pretty sure. So we could do simple things like that and plot where's the activity high. Is it possible to go to this burger stand, or should I go somewhere else? So lots of useful things could be shown here. And of course, I could plot how many different types of phones are there and other very simple but illustrative stuff. But Jacob went on and he did something else. He looked at the interactions between these. So now we are actually trying to work out, did Per and I walk together across the field at Roskilde Festival, and did we interact all the time or just some of the time and then split up and so on? And you can see interactions, one-way interactions, two-way interactions, three-way interactions. And this guy I usually call the pusher. I don't know if it's true. This particular project led to another project which is headed by Sune Lehmann, who has very interesting talks to give, and I'm sure that you will persuade him to give a talk at some time. He has been allowed by the Research Foundation to buy, I think, something like 1,000 or 2,000 mobile phones and hand them out to freshmen here at DTU in exchange for them giving up their geolocation and whatever they're doing on Facebook and so on. And a lot of these students think that that's really neat to have a nice phone here, and I don't mind being monitored. So they do this kind of thing. And of course this means that we can, or sooner that is, can get access to a lot of different information that is coupled in this way. And these projects are very intriguing, very interesting, but they do represent a potential problem. Somebody is watching you. And on one hand, we can do interesting and useful things and help people. On the other hand, we could also harm them. And this is one of the things where big data becomes very interesting, and it is sort of out of my area of expertise, but it's still very intriguing. Here at DTU, we have a smart boulevard. You might have noticed that there's some new nice lampposts set up. They are intelligent and include all sorts of radio sensing equipment and wireless and so on. And there has been some dispute on how and why and when these things are to be used. So this is one of the more interesting things about big data. There's a time before 3 years ago and then the last 3 years in my life which has to do with my work, and the pre-3-year period was when I thought that, okay, big data is just loads of data and we have lots of computers and the computers get bigger all the time, so there's no problem in this. We can handle that. We're DTU Compute. But this project, big data from field to fork, as it were, actually changed my opinion here. So here we have the big data value chain, and we've divided it into sense, think, act, and you can see on one end there's a building block called data origins or sensors. There's data collection, so we collect it and we transport it somewhere. Perhaps we store it on a disk, and perhaps we take it out of the disk again and analyze it, and then we have to take some decision based on that, and this brings us to the consumers. So if you think of this as a value chain in different senses, so this is both the data value chain, but it's also the value chain that it could actually make us some money. There's a similar value chain in any of these domains that we look at. Now we looked at this one with animal health and welfare and health. You'll note that, of course, the value chain here has something to do with growing some fodder on the field, harvesting it, feeding it to animals, processing the animals somehow either by slaughter or by milking them, and then providing this product to the supermarket and selling it. That's another value chain. And you can see the actors down here and the kind of data that they generate. So each of these building blocks will actually generate some data, and they could use this data internally in order to become better at doing whatever they're doing. But the really big thing comes if they could agree to cooperate and exchange data. And this is where big data, again, I hadn't thought of it, but this is where big data comes into play, and this is where it becomes difficult. We investigated the area by interviewing a lot of the companies that you saw, I think more than 20 companies and interest organizations, and there were different areas, and they can simply be summed up here. So for instance, pigs, we noted that, okay, you have to collect some data, so this is a generic thing you have to do. You have to store, manipulate in real time the data, and so on and so forth. Merge and integrate databases, pattern recognition, machine learning. Here's my own topic, advanced statistics using multivariate analysis. And finally, visualization of data with decision support systems and so on. And then I skipped one. Did you notice that one? This one. Privacy ethics. I had no clue that this is really what is determining if we will have success with big data or not. Privacy ethics. Are people willing to exchange the data? If you do not allow me to use your data and I do not allow you to use my data, then there's nothing gained. If we do, if we dare, then there is some low-hanging fruit there that might be of some benefit for both of us and maybe also for the society. Let me show this extremely simple example. So an innovative veterinarian from southern Jutland is looking after a large number of farmers' pig herds, and he thought, okay, I know that the slaughterhouses want us to weigh the pigs once or twice in the growth period before slaughter. So about halfway and then near the end before they are supposed to be slaughtered. But what would happen if I now asked the farmers to actually monitor their pigs and weigh them every week? Could we gain something there? And he did, and he got some farmers interested, and these farmers handed in the data, and the company DLG, which is a fodder stuff company, they agreed to take in this data in a database and then display it to the farmers. So what the farmers can do now is they register their own pigs' weights. It's sent to a central database, and then they can go in and they can have a look at this central database. How is my pig herd evolving weight-wise? And furthermore, how is it compared to other farmers in the same situation? And this created a lot of interest, and Erfagruppe, as it's called in Danish, so they exchanged their ideas and interests, and okay, I'm using this kind of fodder and for this long, and then I wean my pigs and so on. And this turns out to be a great advantage because my pigs are gaining 10% more than before I did this. And actually the farmers who followed this kind of thing were experiencing something like a 5 to 15% change upwards in growth rates. And of course, this also means something on the bottom line. This is an area where the farmers have dared to give their data back in the system to the fodder stuff company, and they have gained more insight into their own data because they get to compare with other data. And the only thing they have done is that they have plotted the points that are there. The farmers could have done that by themselves, but they didn't. So somebody came up with this idea. There's not even a regression line here. It's just a simple line plot of the different points connected. That's enough. So what could we do if we actually did some of this stuff that lots of the sections around here at DTU Compute are really good at? Machine learning, statistics, security systems, disk access, what have we? We cover it all. And in order to help out a little here, we got this public-private partnership together with Innovation Fund Denmark, a pretty large project on big data, which is called DABAI up here. And it contains 4 leaves. So there's a central leaf here, which is generic, and it's concerned with developing the tools that would be needed. And the idea is here to develop tools and tailor them so that they fit for the Danish needs. Then we have to display or demonstrate that we can actually use this in different domain areas, and you can see 3, of which I'll just point out here. The food supply chain data. So the project that we looked at, where we interviewed a lot of companies, has actually turned out to bear fruit, and we are now in business in this project. So I expect to be able to employ two colleagues of yours, two PhD students, on the 1st of December and the 15th of December, if all goes as I hope it goes. And they will then supplement two other colleagues that you already have in the cognitive systems group. And we of course hope to be able to collect this kind of activity and spread it across the department. So what are the needs of the industry? Now I'm turning back to the animal welfare and so on. Well, what are the needs of the industry? You have to know your domain in order to be able to help them somehow. And that, I think, is one of the fun things about being at DTU Compute. You can actually learn a lot about a lot of other domains by just having one competence that is analyzing data. And the problem for the pig industry is that pigs come in different shapes and sizes. But when you go to Tesco, or you go to Quickly, or you go to Bilka, you want to have the same product every Sunday for your lunch. So the bacon must look and taste the same as it did last Sunday and the Sunday before. And in order to do that, we have to be able to either produce pigs that are extremely alike, or be able to handle that they actually are different and then use them in the best way possible as they are processed. And different projects have been looking at this. In the image group where I used to be, there has been quite a lot of PhD projects on this, trying to see if we could use CT scans to better describe what kind of variability are we looking at when we look at different pigs, and how can we use this this knowledge of variability in order to produce better products. So I won't tie you in the image processing details, but this is just to show one way of looking at this. So this means that in the future, in the near future, every pig will be scanned and every pig will be cut up according to what is found in that single scan. And that is quite interesting, especially when you think that in an abattoir of Danish standards, a pig passes by every 5 or 6 seconds. Just to show you, we do have formulas here, but I won't dwell into the formulas. What we're using this for is that we look at the pig carcass and we determine how do we make the optimal cut here. And there are two saw blades here that can be adjusted a little bit as the pig flies by, and it is cut according to the knowledge that we have gained. Spin-off companies have been made of this, and this could be also the future of some of the big data projects. So in the image group, there's a successful company called Videometer who have made this interesting device, and you can ask the image group or Jens Michael Carstensen more about this. It records the image in several different wavelengths. The one that is installed in the image group, I think, has 20 wavelengths. And this can, of course, also create immense amounts of data that need to be handled somehow. So here's an example of some minced meat where it is stored at different atmospheric conditions, and we want to follow the spoilage of this meat. So that's another possibility. This, for everything, since it's less than 2 months till Christmas, this is a Christmas tree. At an abattoir, this is called a Christmas tree. So these are the pig bags as they are put on. And at this point, the tracking, the traceability of the single pig carcass is lost. And it might be of interest to actually be able to recognize the pig carcass all the way through to the supermarket, so that if I pick up a piece of meat that is bad, I know that it was Jens Hansen who made this piece of meat, and I can go back and hit him in the head. I can't do that right now. You could say things about putting chips in and so on, but that is a no-go. Don't think about chips. So think about recognizing this pig back just like you would recognize a face. So there was this experiment made on 40 of these pork loins on 2 consecutive days, and on the first day the pig loins were imaged, and they were processed using this so-called DAISY feature descriptor, which changes the image into a bunch of features which we can handle. And then based on this, both for the first day and the second day at slightly different conditions, we try to see, can we actually recognize the pig loin on day 1 and recognize it at day 2. And to make a long story short, this is done by something called dictionary training. So we try to find areas in a suitably large space, multi-dimensional space, where things look alike, and you can of course see that things cluster around here, and that this might be used in order to describe the different pig loins. So if we use the centers, this gives us a simple description of each of the pig loins, and it turns out that on day 2 we can look back into these descriptors and find the ones that they compare to. And again, to make a long story short, the blue cross diagonal down here shows that this is actually possible, and we can recognize pig loins as we humans are able to recognize faces. Finally, on monitoring animal well-being, we had a PhD project on this. So this has something to do with looking at the behavior of the pigs just before they go to their final minute. They are monitored because stress among the pigs make them taste not so well, and we also think that it's not nice to be a pig if you're too stressed just before you have to go to your maker. So that's another thing we've been looking into. Now, in order to make this useful for society, we have to spread the good word, and since you're all here and listening to the good word, I have managed to spread it, I'm sure, but we have to do this to our students also. So we actually also managed to suggest a big data master profile, which has been running now for a couple of years, 3 years I think. Eventually the first have graduated. Actually the first one graduated just a few months after we launched it, because he had by chance taken the courses that were needed in order to fulfill the profile. So that's useful and creates a lot of interest. We also have hackathons which are put into system now by means of the so-called Open Innovation X, and you can hear Mark more about that if you want. And then finally, we also need to educate the already educated and the business people out there. So we have also the Big Data Business Academy as a continuing education effort. So the data science or big data master profile looks like this. So amongst the 120 ECTS points that you're supposed to take during your masters, you have to qualify by taking at least 45 ECTS within a slightly narrower range of courses. And then, of course, you need to take your thesis within something that we could say was reasonably within the area of big data. And if you remember the building blocks that we had, or the value chain of big data we had before, then we require that the project, the thesis project, actually covers at least 2 of these building blocks, because we believe that one person cannot span the whole value chain, but perhaps a group of people, 2 or 3 or 4, could do that. So we require that everybody knows something about 1 or 2 of the neighboring building blocks. We also, of course, encourage hands-on work. I already mentioned this, and of course I would like to mention that and it's encouraged that this is done in collaboration with companies or other institutions outside DTU. We have experimented with a big data hackathon. This was done during the Big One project that I mentioned some time ago. And this was quite an interesting event. So Lyngby-Taarbæk municipality provided all the data that they could access and could reasonably store on some of IBM's big disks. And then we invited students from all over the country to participate in a hackathon. These students, 65 of them altogether, formed 10 groups, and they were then given 48 hours, no more, no less, at DTU Skylab in order to provide a solution for this goal, namely that they should make a smart city app to make the municipality a better place to live. They did so. They arrived on the Friday, and they kept on working until they sort of fell apart and fell asleep. And I was there during the weekend, and it was quite interesting. I do have some photos from there that I did forget to put in here, but you can see them later. And they really did a big work. 10 groups started and 6 groups eventually finalized. So 4 were softies and left the game. These were the results, or 7 perhaps. 7 maybe. Okay, these were the results, and you can see that we were looking at something that had to do with energy consumption, traffic regulation, and care of the elderly, optimizing bus routes, and flexible waste collection, make the dustbin call for help if it's full. And these were then presented and evaluated by a panel, and there was one of them that came out the winner. That's the top one by chance, and they won quite a nice prize of, I think, was it 50,000 crowns or something like that. And they have now started a company based on this idea. It's called the company is called Picodat, and you can look at this URL sunmapper.dk and see how well they're doing. So that's good, and it creates a lot of interest. The Big Data Business Academy is our continuing education initiative, and this is funded by the Industrial Foundation and is conducted in collaboration with DTU Business, and we also have partners like Teknologisk Institut and the Alexandra Institute, just to mention a few. And the idea is that we invite a number of companies to participate in this event. It's free for this first time. This funding has been provided by the Industrial Foundation, but next time it will cost what things like this usually cost. And the 20 participating companies, all they have to do is they have to promise that they will send, for every day of this education scheme, they will send a couple of personnel. And the big thing here is that we're not just involving people like DTU Computes, we're also inviting people at the executive level. In a company, you'll typically have a time horizon of something like 3 to 6 months to demonstrate that this idea you had was actually well worthwhile and it was lifting off and it's making a bottom line that is other than red. Okay? And if you need to do something about big data, it will typically take a lot longer time. Just to get data organized, our experience shows, by interviewing different companies, is something like 2 years worth of work. This, of course, does not correspond very well to something like 3 or 6 months. So you have to get the bosses involved and get them to think it's a good idea, because then it might take off. And this is the idea behind the program here. So we invite people to come for the trends and fundamentals. This is the DTU Compute flagship, Insights and Analytics, and then there's something more business-oriented, which is scheduled here for November 8th to 10th. You'll notice that these 2 modules have already taken place. And then finally, there's an evaluation module, which is the follow-up and learning what did we actually learn, module 4, in the beginning of spring. So that's a program as it looks right now. I'd like to draw your attention also to LearnT, Learning Technology. So this is the new Center for Digital Learning Technology, which is headed by Helle Rothsen, our new professor. And this has the objective of providing excellence in research and application of disruptive learning technologies. So this is yet another use or another facet of big data. The inauguration of this center will be in just about 3 weeks' time. And I'm sure that it would be nice to turn up there. And one of the reasons for turning up is that straight after this event, we will have our Christmas lunch. Okay, so just to mention a few of the big data activities we have at DTU Compute. On the research side, we have the Danish Center for Big Data Analytics and Innovation. This is the DABAI project I mentioned. We are at DTU members of the Big Data Value, there's a lot of big data around here, Big Data Value Association, which is an EU organization which has the objective of basically lobbying for the EU Commission and helping them formulate the calls that will be coming in the future. So if you want to get involved here, there's also the possibility. DTU is a so-called full member, and this gives us some rights to put forward proposals and help writing the text. If you need to know anything about that, then please address me. So this has to do with the Horizon 2020 calls that will be coming. On the education side, we have our master profile and the business academy. On the innovation side, we have the Open Innovation X and Smart Innovation. And then, of course, the well-known center, or maybe not so well-known center, but there is a center called Big Data DTU, which is an umbrella for the whole of DTU, where we invite centers or departments or individuals to participate and gain insight, collaborate in different ways, hear about experiences and what funding possibilities are available, and so on. So Big Data DTU. And then just to conclude, in my opinion, and I have of course only walked you through my opinion of big data, and other people around the room might have other ideas of big data, and you can ask them if you have specific questions on some of the techniques and so on. I can guide you on who to ask. But I think that big data clearly has an enormous potential, both for the department, for DTU, and for the society. So I think that if Denmark wants to keep some sort of leading edge in some of the areas where we are really good, then big data is one of the possibilities of doing that. I think that this can be done by optimizing the processes across all the value chains that we're talking about, and I encourage you to break down the data silos and become better at interacting. And this is where, again, the soft skills come into play. We have to agree on when is it a good idea to actually exchange data. Is it always a good idea? Yes, well, maybe it is, but sometimes it also has drawbacks. And history has shown us that things can go wrong if data are misused. I'm sure you can think of different scenarios. So this is it for me. I've now used approximately 45 minutes, and I am open to answer the first question.
So let's say